Now that you've learned about the theory of information processing, let's talk about how you can use it in the classroom. How can you use this knowledge in an actual classroom with real kids? First, let's remember what the goal of information processing theory is: to help students successfully process and encode information for future use. In other words, get information stored in their brains and be able to use it again at some other time. So just a reminder of the executive functions, or those things or actions that get information from one place to another in the brain. First, attention and recognition get information from the sensory register to short-term memory, so it can be processed. Then the processing, or how does it get from short-term to long-term memory, happen with rehearsal, organization, elaboration, and visual imagery. So how do we use the knowledge we know about the limitations of or characteristics of some of these memory stores and our knowledge of executive functions? Well, the first way is attention. You need to attract and hold your students' attention so that they're able to even get the information in to be processed. So you want to have an attention getter or a hook at the beginning of a lesson. You want to make sure that they're paying attention and not playing in their desk or doing something else and not paying attention to the content that's being taught. You also want to activate learning. You want to use your students' prior knowledge. So pull that knowledge from long-term memory to short-term memory so that they can use it to help them process the new information. So not only do you want to tap into their prior knowledge, you want to help your students realize that they're tapping into their prior knowledge, saying, "What do you know about?" Or, "Remember when we talked about plants last week? Well, today we're going to talk about the needs of plants. So let's remember what we know about plants." Activating that learning to process new learning. You need to remember that your students are active learners. So you want to make the information or the lesson teaching engaging and meaningful for them so that they do want to be involved either physically or cognitively. You want to make sure that what you're teaching or how you're teaching is teaching in a meaningful way. It needs to mean something to the students. Either it's interesting or it relates to their lives, but thinking deeper rather than just memorizing facts, but making it more in-depth learning. And also organization, one of those executive functions. You want to make sure that you're teaching in an organized fashion. You're not jumping all over the place, skipping from place to place. And you want to make sure that your students are learning in an organized fashion, that they're putting pieces together that fit together and not learning in isolation or making connections that don't really make sense. So helping them learn in an organized manner. Two ways that you can do this is through an advanced organizer, which is a graphic organizer or some way, an outline, a picture that helps students understand what they're learning about. An advanced organizer happens before the learning takes place to help orient students, and a graphic organizer is any organizer that's in a graphic manner. So you completed a graphic organizer about punishment and reinforcement. It's just a visual that students can complete either before, during, or after to help them organize their learning. Let's talk some more about the idea of meaningful learning. If you look at this graphic, you can kind of think of it as a swimming pool, where the parts above the purple line are the shallow end and the parts below are the deep end. So we want our students to be swimming in the deep end to really have a good chance of learning, effectively encoding and storing information. So on the shallow end, there's maintenance rehearsal and rote memorization. Maintenance rehearsal is rehearsing, repeating things over and over in order to maintain them and eventually get them into long-term memory. Rote memorization is memorization of isolated facts, writing your spelling words 10 times, doing your math facts in isolation. It can lead to learning, but it's not as effective as some of the deeper processing activities like visual imagery, organization, elaboration. Those lead to more effective encoding so that students are able to recall that information when they need it, so that they have truly learned what you're trying to teach. Another way that you can think about meaningful learning is with Bloom's revised taxonomy. A taxonomy is just an organizational way of categorizing things. So you have a taxonomy of animals, a taxonomy of plants. The animal kingdom is a taxonomy. So Bloom's revised taxonomy gives us a way of thinking of what is some of the deeper processing and more meaningful learning, and some things that are less meaningful. So here's a graphic for Bloom's revised taxonomy. I just like it because it's pretty and colorful. If you Google it, you can find all different graphics for this. But take a minute to read the words around the outside of the orange and see if you can figure out which one is the lowest level of thinking, which one requires the least sophisticated level of thinking. So if you haven't guessed already, it's remember. Remembering is the least sophisticated level of thinking. Next is understand. The next is apply. Then analyze, evaluate, and create is the most sophisticated or the highest level of thinking and learning. So when you're thinking about meaningful learning, sometimes we do need those lower levels of thinking, that surface level learning of remember and understand. Students do need to know that information, but you want to make sure that you're not hanging out down there. You want to include some of those analyze, evaluate, create, to make learning real, to have deep processing, so that they'll then be able to apply that information later on in their lives. We don't want our students just to be able to know things from kindergarten and only in the kindergarten classroom, or only in third grade, or only in eighth grade. We want them to be able to build on that information and use it throughout their lives. So analyze, evaluate, create helps students to more effectively process information and then be able to retrieve it from long-term memory. So some more ways that you can use information processing theory are through memory aids, overlearning, automaticity, and metacognition. So let's talk about memory aids very quickly. Memory aids are some mnemonics or ways to help students remember information. Please excuse my dear Aunt Sally for the order of operations, or Roy G. Biv for the colors of the rainbows. Those are mnemonics. There are tons of mnemonics which you can read about different types in your textbook. You can also use overlearning. Overlearning is learning past the point of initial mastery, so that you've learned it, you know how to do it, but you're going to keep practicing, or have your students keep practicing and reviewing that information so that it becomes almost automatic. You don't really have to think about it. Which brings us to automaticity. Automaticity is being able to do something without thinking about it. That unconscious retrieval, being able to tie your shoe, brushing your teeth, those are automatic. You don't have to think about how do you do those things anymore. Automaticity is useful because if things become automatic, they don't take up room in your working memory. So you could carry on a conversation with someone or try to remember something while you're tying your shoe. Probably not brushing your teeth, but that's for a different reason. But it helps you use that limited capacity more efficiently, the limited capacity of the working memory. And also metacognition, thinking about thinking. We're going to talk more about this on Friday in class, but metacognition is thinking about thinking. And this is useful because if people are aware, if students are aware of what they should be thinking, how they should be using information, it makes it more meaningful and more effectively processed. So most of the ways we've thought about using information processing theory have to do with those executive processes. But let's talk a little bit about the characteristics we know about the working memory, where the information is really processed. The working memory has a small capacity. It can only hold 7 items plus or minus 2, so 5 to 9 items, and can only hold it for a short amount of time, about 20 seconds, without processing that information. So some ways that you can prevent cognitive overload, which is putting too much information into the working memory to be processed at one time or expecting it to last for a long time, are chunking, dual processing, automaticity, distributed practice, and think time. Chunking is putting groups of information together so that they become one piece of information instead of separate pieces. For example, I can think about the days of the week as a group of items. I don't have to think about Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday as 7 pieces of information. I can say days of the week and know that that's one piece of information. So the rest of my working memory is available to process other information that I'm trying to think about. Dual processing or dual encoding is this idea of processing the same piece of information in 2 ways. So visually and with auditory or hearing it. Seeing something and hearing it. Seeing something and smelling it. Hearing the name of a spice while you're smelling it makes it more meaningful. It's going to be more effectively processed than simply hearing the name of the spice. Automaticity, we've talked about, that helps prevent cognitive overload as well because that piece of information is unconsciously brought in and retrieved. You don't really have to think about it or reprocess that information. Distributed practice is the idea that you're practicing something little bits at a time over time rather than cramming it all in. So in order to prevent cognitive overload and in order to more effectively process information, it's better for you to study for a quiz a little bit every day rather than cramming the night before or the morning of your test. So distributed practice, practicing a little bit over time, is more effective than mass practice. And the idea of think time or wait time, which the Stahl article talks about that you'll read or have read, of giving students some time to think about things. When you ask a question, instead of immediately asking for a response, letting students think about it, process the information, rather than peppering them with more questions or more information. So those are some ways that you can use your knowledge of information processing theory in your classroom. So when you're observing at South Wayne, see if you can find any examples of teachers using chunking or think time or meaningful processed or students using automaticity when they're working on their work. Look for those things. Look for prior knowledge and see if you can find them in the classroom.